So, Iterators Generators, that's a bit about me. I'm a front-end developer at Xander at the moment. Um, also, my website is thatguy.coza. Professional string concatenator and CSS, JavaScript, PHP Wrangler. Alright. So, iterators. What are they? They're basically a means for you to iterate over things, as the name explains. But you get different ones. The big thing is that whenever you use a for each loop in PHP, it actually creates a copy of the array. So this is something I didn't know originally, and it doesn't seem that important, but I think when you're dealing with large data sets and you start seeing PHP using 4 gigs of RAM, then it's definitely something you can look into to help with efficiency, like efficiencies in there. So if you can see here, I've got items which is basically a colon separated string. I just explode them. I get an array and I create an array iterator, and you iterate over it like you would do normally. So it's not super technical or advanced or anything. To see that in action, let's do this, if I can spell. And then that. I'll make the code available so you guys can have a look at the examples and see what it's doing and so on. So it's just basically running through that and printing it out now. I've got this little snapshot that it prints out. At the moment, there isn't much difference between an iterator and a generator. You only really start seeing it with larger data sets. And I'll go through that in a moment. Let's go back to the presentation. So, why the hell even bother? Like I mentioned, for each creates a copy of that array. I know, especially in our system, there is definitely places where we need to use this. We've got large data sets and we're just for eaching over these things and hoping for the best. Let's have a look. No, sorry, I was running PHP 7, but the same thing applies. It's been around since PHP, I think it's 5.3. So any system PHP 5.3 up. I've got another. I'm basically running PHP in a Docker. So the same thing run on PHP 5.4. Oh, sorry, 5.6, not 5.4. Same thing run on PHP. 5.6 is actually faster. It's funny thing I noticed with PHP 7 is faster with large data sets, slower with small data sets. Quite funny, but probably because they're looking at like massive frameworks like Laravel and they're optimizing those. So the actual routines that those run through versus the small ones. I don't think the op caching is quite as good. So yeah, we've got a whole list of iterators. It's a lot. There's really a lot that's in here. You basically, if you're struggling with a particular aspect, memory usage, if it's objects or arrays, you would use the particular iterator, object iterator, or a file system iterator, or an array iterator. Let me just have a look. So this is the recursive directory iterator. Now you get scanner, if I'm not mistaken, which is kind of, it can scan a directory, pick up files that you want to process, and so on. Well, this is the SPL iterator version of that. So basically what I'm doing is I'm just creating a new instance of it. I'm giving it the path, which I'm mapping in my music drive, and I'm saying that it should skip the dots. So that's when you get the like directory dot dot and dot. And as usual, you iterate over them with a for each. So what that looks like, if I get this right, is like this. So it is an iterator, it's not a generator, it's an object. It used 250 KB, 260 KB of memory, and it's got my directory of my music, so nothing special, but it is super efficient at it. So the same example, oh yeah, sorry, let's get to this one first then. So the only thing is that it is an iterator interface, it's not an array anymore. So if you try and use array methods in that for each, you will most likely get exceptions and whatnot, particular to the type of thing you're trying to do. So you're trying to run, I don't know, count against an iterator, which is kind of like, it basically takes that array and it creates pointers and it just knows for each one, go and get that particular piece of data. So it maintains the internal state, whereas if you have an array, it creates the copy and it just iterates through them as well. Not very efficiently, unfortunately. Oh, sorry. I seem to have deleted one by accident. No, here we go. Sorry about that. So the recursive, sorry, this is what I was looking for. The recursive directory is basically iterators are one level deep. So if you, for instance, now do the directory iterator, it will only do the base directory. But if you want to do the whole tree, you have to run it through a recursive iterator. So you see here at the bottom, the only real difference between the previous one and this one is that I've wrapped that iterator, that previous iterator, in a recursive iterator. And it's quite interesting what the result is. Let's have a look. So this is the same music directory, but now it's found 1,000 records, whereas previously it only found the top level ones. So let's have a look. So 1,000 ones, and you can see it goes all the way through all the directories. Now if we go further into this, I also mapped my wallpaper directory just as an example. And there we've got, oh no, wait, there's something not right here. Ran the wrong one. So there's all my pictures. And it's by directory, all the entries. Now if we go further, if I run my whole home directory, now this is quite large, just bear in mind. That's my whole home directory. It's pretty fast. I mean, most of the time is actually spent in printing this out, not in iterating over it. If we see now, after this finishes, it will have the printout of the execution time, and it's literally since the script started till when it ended, and that's how long it took, and it's much faster than this. Same with Python at times when you try and print stuff out at large scale. Any moment now. So there we go. I mean, peak memory usage 548 kilobytes to actually traverse my entire directory, 138,000 files scanned basically. So the whole tree. And if you look there, 6.5 seconds. So it is super efficient at doing this, as long as you don't print it to stand it out. So and then, yeah, iterators, they're not super complex. They've been around for quite some time. I just think we don't really know about them. They're used extensively in the frameworks we use, but in general, it's not something that was, I don't think it was publicized a lot. It's really simple to use. It's literally, you have a big array, wrap it in the iterator, iterate over the iterator. It's that simple. Where you have to access the keys and the child keys, then you'd use a recursive iterator for that same thing. So super simple. Onto generators. So the only thing is this is fairly new, and fairly new is 3 years old already. So I don't know. It says something about the state of our code bases, I think. 5.5 minimum, and it adds the keyword yield. So a lot like iterators, generators are kind of a wrapper for iterators, if I understand it correctly. And it adds additional functionality. So this yield method or functionality that it gives you is pretty cool. It basically, instead of, if you have a method and you have a return value, when that return value is hit, it will return that value. But yield, you can actually have multiple yields in a method, and each time the method is hit, so to speak, it will yield the next value. So it's kind of like a pipeline in my mind in a method. So let's have a look what that. So where you have, for instance, a yield, a return. If you run a method, a function, and you expect it to return true or false, then it returns true or false, and once it hits that return statement, it's done executing. You can hit it once and that's it. Whereas generators basically you can have multiple yield statements, or you can have it in a loop, and you can yield return multiple times without calling it multiple times. So you've called it once, and it has internally constructed all the returns. And as you for it over it, I'll show you in this example, for instance. This is, in my mind, a good example. So I have lots of yields there. I've defined a method, and it basically yields a line at a time. So the problem for me initially understanding this was I was expecting it to hit the first line, and that's where it stops. That's kind of not how it works. It wraps the whole method, and it figures out that there's five times that it can return, so to speak, a value, yield a value, and you then in for each can then get each of those values individually. Let me show you what this looks like or what it will output. So as you can see, that code echoed out all of it. So it yields every single one of those values in the for each, and one at a time. So for each yield, it's returning a value at a time. I'm pretty sure you can, yes. So so if you, for instance, pass an object by reference, and that object in the method gets changed, and based on its change, it can do different things, you can do that. It'd be terrible to read, and to figure out what the hell's going on there, but you could most definitely do that, yeah. Um, the best example I could find for its usage is um, Facebook uses it for coroutines. So to simulate multitasking with PHP. So something that's single threaded does one thing, you can actually then coroutine a hell of a lot of stuff and have them all work together in different ways. But I'll show you an example a bit later. Then let's go back to this one here. So this is what I meant. If you look at this, okay, I had to wrap it in an array bracket so it would work for a for each as is. But that's kind of what we're expecting, right? We're kind of expecting that it's only going to bring back that value. If you look at the yield, so to speak. So that's where the key difference comes in. This stops there. It's returned. The method's done what it's supposed to do. None of this even gets evaluated. Whereas that, each time the for each is run, it will iterate and yield a new value, the next value. So I don't know if you've ever seen the like next and current, and it was something that was introduced in arrays functions, and that's the iterator version. So generators working with iterators, keeping track of where it is and yielding the next one. Yes, exactly. Exactly. It's a normal function as any, and you literally you yield whatever value you need at that particular time. Yeah, no. Iterator is an iterator. Generator implements an iterator. If it makes any sense at all. Yeah, well, it extends from it. It basically at its base extends from it. Yes. No. That's all managed in PHP for you. Obviously, I mean, it extends from it. So internally, if you print out, let's have a look at that previous one. I'll show you what I mean. So this prints out is a or is type. So it's both. The generator is both a generator and an iterator internally. So at its base, it's got the iterator functionality like we saw earlier, where it just basically goes from one to the other, but it extends it with that yield, and I'll show you another example where it becomes bidirectional, which is quite tricky. No, you literally have a function that yields, and it internally knows that it is a generator now. Yes. So this is like not necessarily. I can instantiate a variable and then pass the variable into for each. It's still the same type underneath. So since PHP 5.4, it's kind of the same thing where a return can be used directly. Previously, you had to instantiate it, get the types, then try and consume it. So like I mentioned, yeah, see that only that one was returned. Obviously, the return has done its job. It's over. It's finished. So another example of this is, so here we've got again no return. So if we look at it, it's basically just a for each loop. So sorry, a for loop, and it gets wrapped in a for each. And you have these little helper methods because there has to be a method that returns a yield for it to be a generator. So there has to be a function. You can create probably an anonymous function and pass it into the for each. It would be super ugly, but it would work. And literally all I'm doing is I'm iterating over 1,000 of these, and I'm just printing out one value after the other. So it's not super obvious maybe looking at that, but in this yield, you can think of it like it's keeping or track of what I is. And internally it knows, okay, I has been returned, so to speak, yielded 1,000 times. So if we look at the example again, so I'm printing out every 100 of it. You can see it is an iterator and a generator. If we go back here, you see that echo gets echoed as per normal, but it's only echoed once. So it's not like this method is being called multiple times in the background. It's only called once. And the yield portion of it then keeps giving back values to the for each. Yes, exactly. So a return that doesn't stop executing. So, so sorry guys. To show you guys now, that was a generator version. So literally a for each version of that same thing. So it uses a little bit more memory. It's not a big object. It's 1,000 elements. It uses almost double the memory. And you can see it is type of an array. It's not a generator, not an iterator. Now, if we amp up the ante, and it's not by much, so if we go for a generator iterating over 10 million, so okay, it's a large amount of content it's going through. But if you think about it, our systems can have a shitload of data at any time it's fired up. So over a whole, it is possible to have this. So iterator maximum memory it used was 266 kilobytes. Sorry, and it's tiny. It's super tiny. It took 14 seconds to do that. Now, if I had to compare that to ye olde just for each and a range, it's going to take a while. Am I even running the right one? Let's see. Okay, well, I ran out of memory, I'm sorry. So, let me try that again with PHP 7. I know it works with PHP 7. It's a bit more memory efficient to the core. So let's try it with 7. It is definitely more memory efficient. So even even then, 4 gigs of RAM down the drain. It's for one thing to execute, given it's a large data set, but it's a simplistic data set. It's one number, one integer it's ranging over. So yeah, obviously, unfortunately, like everything else, there's a performance hit when it comes to these things. It now has to internally keep track of where the fuck it is in the operation, so it's going to come at a cost. So which is the cost that you'd rather pay? Iteration time or memory usage? And I'm pretty sure people will go with hardware cost memory usage, then you're going to wait a second longer for your stuff. Well, okay, to be fair, this is PHP 7, right? So let me run the same one that we had earlier on 7. So let's be fair, for what it's worth. It is supposedly more memory efficient and faster, so we'll see now. So that took 6 seconds. It's still faster than 5.6. Like I mentioned, it's, I don't know, better at large data sets. 408 kilobits versus 4 gigs. Just saying. So it was 10 million iterations it basically went through in doing that. So this is a bit more of a chunky one. So a lot of the examples you'll see is similar to this. It's basically a method opens a file handler and for each line yields the line. So if we compare that to how you would normally read a file, I'll show you the difference. It looks quite scary. Initially when I saw this, I was like, what the? So eventually it sinks in, just as long as you think. I like to think of it as like a loop in a loop. So this little method only gets called once, but it can return multiple times, if not millions of times, versus a normal return once, exit, I'm done. Thank you. So if we look at the example, this first one, I'm going to do a small file. It's really not large at all. This is using a generator. It's basically reading through one of the free online ebooks. The file itself is only 600 kilobits. It's only used 400 kilobits to iterate over 600 kilobits. So it's pretty cool. And it's super fast as well. I mean, that's 0 seconds. If we compare that to the vanilla read file, as per normal, this uses array or used file get contents to do this. And same thing, but it used magnitudes more memory. 3.2 megs, it's about 6 times the memory it consumed, and it took a bit longer. That's really where it starts to shine. If we take a large-ish file, I think this was about 20 odd megs. So it's a generator, 20 megs, still 400 KB, and it generally uses 400 kilobytes. I don't know exactly how it does that. Obviously, it has been optimized to hell and gone. So if we do the same one using vanilla methods, now we start using 90 megs of memory to process a 20 meg file. That's no processing yet, sorry. That's literally opening the file, reading line by line, and printing out the first 10 lines or whatever it might be. And generally it's super fast. I mean, 0 seconds. I don't know, how many of you have gigs worth of content you have to crunch through? I mean, I think it can be quite useful to do something like this. So another example is generators introduced. So I said they extend from iterators because iterators have very basic functionality. It's like last, current, next, and that's how it keeps track of where it is in the array. Generators have a send method, which is the extra one, specifically for generators. So as soon as it sees a method with that yield statement, it knows that, okay, this is a generator, I can now also send to it. So same thing as before, we open a file, and while the file's open, with no errors, we basically yield, but you would expect it to now yield back. But because we're sending to it, it's actually writing it to the file. So let me show you what that looks like. So there's the file. Just escape past the craft. And there we go. It's written to it 4 times. It's only used that method once, and it's written all 4 entries. And what's nice about that is that it can only do one at a time. So there's no way that you can have multiple files open. If you have this one method, it dumps out logs, it writes it. So what stops you from using a plain old class and doing this the same way? Nothing. Literally nothing. I suppose it becomes important again when you're dealing with large data sets and you have to just do like a little chunk at a time. Let's see, I still have. So unfortunately Docker is quite slow at firing up, so I would have liked to have done this every like millisecond, but it takes a while to start Docker up and tear it down. So but as you can see, it just pipes to it. Into the function, yeah. So the method constructs, it's got the yield, and I'll just write to it. So a lot of people, I'm not smart enough to understand it, unfortunately, but I've seen guys apply this to sockets, to various things, you know. It becomes a bit like, what the hell is going on here? So hopefully if I understand it a bit better, I'll be able to do stuff like that. Let me just kill this puppy. Die. So let's have a look. So something I wanted to show you guys. I did put his article there. This is the guy. I read this article and was inspired to do the talk based on that. Nikita Papov. He is a genius kid in Berlin, core contributor to PHP, and really introducing. He was like one of the guys that pushed for generators to be introduced into PHP. So much smarter than any of us, unfortunately. Like a physicist come PHP programmer. I don't know why, but okay. Pretty cool. And he basically wrote this article about coroutines, and I'll share this with you guys afterwards as well. But just to give you an idea what you can do with generators. Now, I wouldn't suggest you do this necessarily. I don't suggest you replace Nginx anytime soon. But you can basically build a pretty concurrent system using PHP generators and coroutines. So let's fire this puppy up. Index.php. Here we go. So it's now listening on port 5000. Just write little HTML. There we go. And PHP serving its own content, basically. And it is pretty beast, I must say. I'm going to run a Apache bench against it with 10,000 hits. So let's have a look. So that is 10,000 requests done in, how many seconds was that? Can't see. In 1.4 seconds. 10,000 requests, 1.4 seconds. PHP. Just saying. So I'm honestly not suggesting that you do this. That was just plain HTML. It wasn't actually interpreting anything. But it's not to say that you can't have it interpret PHP on the fly as well. And that's what that does. It basically is a R printing out the current time every time I refresh. So PHP serving PHP, a bit of inception, but pretty cool. Like I said, I won't replace Nginx anytime soon, but it's cool to see that you can do some pretty hardcore stuff with it. Probably wouldn't be able to do that with anything else of mine. So I'll share this with you guys. You guys can check it out. See his article. Read his article. It's very lengthy. It's very detailed. I didn't understand it. I had to go and get his code to get it working. Super bright kid. So getting back to here. So yeah, stages of generators. Pretty much. And then yeah, I've been using PHP 7 here. I wanted to show you guys just two things that I've since discovered since using PHP. Apparently, up to 100% improvement in most frameworks. I don't know how true it is. They obviously very biased, but why not? If it's faster, why not? So I don't know if you guys have read the new features, but PHP 7 brings with it the null coalesce operator. So it's a little double question mark. And basically, it's no more if empty, this ternary, that default value. It's basically if this is set, that's the value. Otherwise, this is the default value. Super awesome stuff. Can't wait to start using it actually. And then, no, I believe it uses empty internally. Yeah. And then, this is something that got me. My framework is kind of a custom written framework. I wanted something lightweight, and PHP 7 brings with it the error class, which is used for all the internal error handling. It kind of broke my PHP very badly, and I wasn't sure what the fuck was going on. So just a gotcha, basically, on that. Yeah, and that's about it. So, any questions from you guys? Sure. This one, or would you like this? Okay. we'll stay here. It will be a generator, yes. It will be a generator, yes. I don't know if I can show this. It might. No. Wrong one. Let's see if I can quickly get to this. So I'm all for showing rather than show and tell. Let's have a look. So that one was 0.1. Iterator return. So I don't. So this one. So if I assign it before using it, it's still gonna be a generator. I just did it for brevity, basically, so it doesn't take up all the screen space. So still at 0.1. Let me kill some of the stuff. I hope if I can type there immensely. So, same thing. No. 0, sorry. And syntax error. So still the same thing, it's still a generator, an iterator. It's just that at the time of either instantiating that method or assigning it, it knows that that is a generator. Because it scans it and sees that it's got the yield method or system call in it. Yeah. So it makes it a bit interesting, eh? Yes. Sorry, right off the sorry. I suppose it will be the IO. If you can conceive it, you can do it. I can't conceive it. That's the problem. It's too complex for me. It really is. I haven't quite grasped it to that level yet. The Diatu example, the server example I showed, actually has non-blocking I/O, and that's how it's able to serve 10,000 concurrent views within like 2 seconds. Yeah. Exactly. He wrote. I would definitely suggest. I'm going to release the notes and so on as soon as I can. But I definitely suggest reading his tutorial. He goes through it in detail. Although it is, I don't think it quite matches the working code, but you can get the gist of it. But he created a whole task scheduler and routines around this, and basically green threading in PHP. So literally have a pool of operation. It just pops them off, does them, and they all work. Or he actually spawns processes, if I'm not mistaken. In PHP, spawns processes, pool of processes running, just waiting for work. And as the yield gives them work, each one works and gives back a response. Super, super interesting stuff in PHP. It's not just Node.js. You've also got non-blocking I/O. It's a bit technical, but hopefully they will actually bring this into the core of PHP pretty soon. You know, although this is already 3 years old, how many of you knew about generators? 3 years already. So it is, like I mentioned, I mean, Facebook uses them for multi-threading in PHP. And that's generally what they do get used for. But I suppose it's up to us to invent new uses for them. Yeah. Dealing with large data files, that's already a win. Sockets, yes. Well, the PHP or the web server is a socket server, and it's 10,000 requests per second, 2 seconds. It's good. And that's probably my puny little laptop. Yeah, I'm sure if it ran on production hardware, it would be much better. So, oh yeah, sorry. Yeah. So it could yield anything. It could yield a new curl request. It could yield basically anything. Anything you can call in PHP, basically. Mm. Mm.
So then that's exactly what you'd use it for. So you yield, it would get your thing, and you could just then loop.
But in case where I want to get, probably say I have to get authors, and then for each author I want to get all the articles. Basically, let's say
Yeah.
10 articles per author that I want to display on a page.
Yeah.
So I get 10 authors, and then maybe say 3 articles each. So I have to do. There's no. Let's say there's no other way. So I have to do 2 calls.
Yeah.
So if I use that method, would it be very efficient than how I would normally do it, getting a result set of all the authors and then looping through each
Yeah.
author and getting articles for that author?
Yeah, you can do nested yields, yeah. So in the for each you can go and do more stuff, same as any other for each, but obviously it comes at a price. It comes at execution
Do you
time
think
and
it would take longer, or it would,
well,
if I
you,
don't use
It would
more
probably
memory?
take the same, but your code would read a lot nicer.
yeah,
Okay, so
It would be more memory efficient as well.
definitely.
If you were printing the standard out, then at least it would print as each call's done instead of only once all the calls are done.
but would it be very advisable to use it in like background processes, or
Mm,
would it be faster, or not use any memory at
well,
all?
yeah. Well, anything really that is time consuming or memory consuming. So if you have something that goes and collects all these articles and then only goes and writes it to a file or something, it will definitely be more efficient at that. At least use a lot less memory. So not like you get a 2 a.m. neurotic alert because a cron had to kick off and oh shit, you don't have enough resources on the server, you know? Or shit just dies halfway through and you don't know why because it ran out of memory. Oh, neurotic alert. Okay, cool, makes sense.
Yeah, I just want to
Mm.
try it on
Yeah,
top of the API, like testing stuff and see how it actually, if it improves the performance of
yeah.
results.
No, I mean, for us at least, I can definitely see us using this where we have large collections of products, and each product has symbols connected to it, and each symbols has the color and all these attributes associated with it, and it chows a lot of memory. On my laptop, it dies a lot of the time. So our servers, or luckily enough, has enough hardware to deal with that, but it's definitely something we can look at to improve it. 400 kilobytes versus 5-6 gigs of RAM. There's no contest really.
Yeah, I always have the memory issues using the standard way. So I think that actually will come handy.
Yes. Sure. Yeah.
I'm full of it today. Just something that occurred to me based on Derek's question. Could you do recursion regarding this or using this? I.e., you in a loop call a function that yields, and then you send whatever the yield has given back to you back to that to the function. So you basically recurse. You send what the yield gets back to you.
I think what you'd have to do is you'd have to have a function that in itself calls another function but does a send to that. Let's see if we can test this out.
It was a theoretical question, like
Yeah, but so basically the yield output,
yeah.
I can imagine you wouldn't yield, or you would yield it, but the yield would then go to a send of another one. Yes,
Mm-hmm.
and in that way you're recursing one to the other.
So you, okay.
I think I'm not sure if you nest them directly, if it doesn't just bubble up to output. So if we let's test it out, shall we? Mm, I shit. I don't even know how to type this. I think it is I is the 10. This might be JavaScript syntax. I'm just worried. I'm not sure. Ah.
I equals 0 with arguments.
Oh yes, there we go. That will help already. Thank you. So what happens if we do this? If I can type. I don't know why the laptop keyboards have to be so different. And then I. And this was 0, 0. Let's have a look. Oh shit. It looked like it actually yields after it. Interesting.
Well, it was the last element in that, so
Move it up.
it would go after every other one, yeah.
I wonder. Oh, it isn't necessary for that. That's why it was doing that funky shit. So yeah, it forms part of the yield. Yeah, you definitely have to send the yield to another generator for it to recur.
Because sorry, I'm keeping on this, but it's not that you're in front of the keyboard and typing. I know that. So in your the bottom for each, if you send whatever the result of SAS is back into the SAS function, look, that might just create an infinite loop. I'm just wondering if.
I'm not that good with recursion to start, but let's try this out.
Why don't you go first?
I'll play around with it. Yeah.
Let's try this out. I wonder what would happen. It's quite dodgy. Oh no, but then you have to. No, I think this thing is going to infinitely recurse on itself.
So again, look, I was just wondering if that was.
Well, let's see if I can break PHP 7. I'm pretty sure I will. And then we have to send. Yeah, well, now you have to write another method because it has to be something that yields it. And then we're gonna yield rand. Almost
A few hours later.
Yeah. I don't know why. That is fucked up. Screw it. Let's do that. So we are. Suppose you could do that. This is going to be interesting. It will probably, it's one of two end results. Either it will fall on its face, or PHP will. Did I? Hold on. Where? Oh, you son of a... That's why it was bitching. Okay, so in my mind it should only yield 10 times. So for every yield it's gonna run it to send it to test. Oh no. You have to wrap this in a for each. No. No. No, let's see.
Maybe not everybody wants to send one.
Yeah, no, it's broken.
Thanks. Okay.
Okay.